last class we were talking about lines, right? When we had that computer program, we had a scatter plot where it actually, all the dots actually made a line. Okay, we had a little discussion on that. So here we got an example of 3 lines that we could have gotten from another computer program. So how can we describe these 3 lines? How can we describe the differences? Vincent?
They all have different like slopes. They're sloped.
Oh, what's the slope? I have no idea what the slope is. Oh, steepness. They use steepness, I know. So they all have different steepnesses? What do you mean by steepness? How can we define steepness? Not necessarily mathematical terms, but just in everyday terms. How can we use steepness? Sarah?
We could say how close it is to a 90-degree angle.
How close it is to a 90-degree angle?
Or
I think
vertical one.
I know what you're trying to say. So yeah, 90-degree angles from the ground,
Yeah.
right? So how close it is to vertical,
Right.
right? You guys just went to St. Anne.
Yeah.
Can you describe steepness from where you were? What's the thing that you guys do? Me?
Well, isn't it like how fast it kind of drops in level over time, sort of thing? Or
Over time, or even how fast,
distance?
yeah, how fast it comes up and down based on how forward you go, right? So if you go skiing, right, if you go on a really steep hill, right, you actually come down really fast if you actually move over a meter or a foot, right? But if you're going to like the bunny slopes like me, right, it drops down maybe a little bit by moving, not go really far out. So that's how we kind of define steepness. Anything else? How would you describe these differences? Matthew?
The second line starts at number 2 on the y-axis.
Okay, so second line starts at yeah, 2 on the y-axis.
Yeah.
Okay, anything else? How are we going to describe the differences here? Pooja?
Number 3 isn't increasing, it's decreasing.
Oh, so it's going down instead of up.
Downward.
Okay. So 3 is going down. And not up. Anything else? Any other differences? Jenny?
Partial variation and never mind, they're all partial.
Yeah, they're all partial. Good attempt though, good drawback on the last lesson. Anything else? Pooja?
They all start and end in different places.
Okay, I'll start and end in different places. Matthew?
The first line starts at one of the x-axis.
Okay, so they all start at different places and in different places. Okay. Anything else? Different colors, that's obvious.
And then
Well, you
it
said
says
not to
beside
say. You
side
said-
color.
I know.
Besides the
You
color.
said not to say it. I said
Jenny?
it.
Oh, you said Jenny, Leanne?
They go up at different,
And they're both it's different amount of steepness, right?
Yeah.
Like, if I was, how many people ride bikes? Riding up and down a hill? So if you were riding up a hill, which hill would you want to ride up? The green one or the blue one?
Green.
Green, right? It's less steep, right? If you're coming down a hill, Which one you want to come down?
Or one.
The one,
Well,
right?
you
The
know,
one's a
maybe
little more
two,
steep.
because one is
Yeah,
like
two.
too
No,
intense.
I was
No, one is No, intense, one. man. One's good.
If I like had my brain to it.
So what,
Yeah.
so what we know is that here we think we have different levels of steepness. Which one is the steepest?
One.
Okay, so I think we're all in agreement that one is the steepest. Which one's the least steepest?
Three.
3?
Three has
Two?
some negatives.
Three is a different
least
space.
I think this one.
So how many say 2? Raise your hand. How many say 2 is the least steep? Line number 2, the green one. That was the least steep. So 1, brave soul over there, Austin. Good boy. Who say 3? I'm guessing everybody else. Why did
I don't know.
Okay. Well, why do we say 3? Paul.
Well, if you look at the second points of lines 2 and line 3, you see that line 3's second point is a lot farther across the x-axis than line 2's second point. And this means where if it takes it longer to get from point to point, when like, you think about the x-axis, that means it's going to be less steep naturally.
Okay.
That's pretty simple.
Yes. Anybody give me a different explanation? Megan?
Number 3 is more horizontal than
Is more horizontal. Nothing wrong with your answer, Paul. Okay, it's good.
There's too many big words.
But how many people think that, well, 3 is the least steep because it's going down?
No, that's
Thank you for calling me stupid.
I thought it was a good idea. I thought
Because that's what I thought. Right? I mean, it's the least steep because it's going down.
But steepness can be like down or up. Yeah.
Okay, so steepness, so it really doesn't matter which direction, right? It's going up or down, right? But it's like how fast it goes up or down. So another point is that steepness does not depend on direction. Okay? Any questions on that? Well, Vincent kind of touched on it already. There's a mathematical term, it's not called steepness. What we actually call it is slope. Okay, so we're talking about slope today.
But then direction does affect slope, Mr. Tan.
Direction does affect slope, but does not affect the steepness
Of the slope.
of the slope. Okay? So here we have slope. So it's represented by the variable m.
Why?
Good question. Who can answer that for me?
I forgot.
Because it's your choice of.
Well, movement.
Movement?
No.
Why is it M?
Because it's Mr. Tam's.
I have absolutely no idea. Any idea why it's called M?
Why is it M?
Mrs. Tan.
Some mathematician out there who first thought of this that I'm gonna name it M. Anyways,
S equals R aroused divided by 1.
write this down. So be familiar. It's represented by the variable M. Okay? And it describes the steepness of a line. And it is calculated as. I will once people get caught up in writing. The slope, represented by the variable m, describes the steepness of the line, and it's calculated as, and note, is always a fraction. Always a fraction or a ratio. Always. And it's calculated by the formula m is equal to rise over run.
I remember this.
Okay, rise over run. Draw yourself a little grid. So let's say we have 2 points. So let's say, remember this? 0, 1, 2, 3, 4, 5. 2, 3, 4. Let's have a point right here. And I have another point right here. Okay. So we have 2 points on our line. Try this again. So there's our line that goes through our 2 points. So now I want to calculate the slope. So how do I calculate? First of all, let's choose our 2 points, the order. Which of you guys want to be the first point? Point 1.
1,
Which one? Which one, Nate? This one or that one?
1.
This one here? So we just label this as point 1. So we go from point 1 to point 2. So here's slope, m is equal to. So in order to get from this point to this point, point 2, how many units have to go up?
2.
You go up 2. So 1, 2. So that's my rise. And how many do I have to go across?
4.
4.
4 to the left or right?
Yeah.
To the left?
No,
To the
To the right. 1, 2, 3, 4. Alright. So it's just 2 over 4. You want to leave your answers like that?
No.
No,
I
right?
want it to be.
Always want reduced fraction
1 over 2.
to 1/2. So that's how you calculate your slope if you're given a line on the grid. So question, do I always have to start from that point, point 1 to point 2? Does it matter the order?
No.
No?
And any
As
point,
long as it's, like, in a little section between sections, an intersection.
Okay, so before I get there, what I want to do is I want to define rise and run. So rise is the vertical distance between 2 points. And I see I forgot a bracket there. So rise is the vertical distance between 2 points. It's positive if you're going up. It's negative if you're going down. Okay, so sort of similar when we talk about positive and negative correlations in the last unit. So it's positive if it's going up, negative if it's going down. Run, which is the horizontal distance between 2 points.
Why does it matter if it's going up or down?
Because it's how we get to the other point. So sometimes we have to go up to get to the point, sometimes we have to go down. So that affects whether it's positive or negative.
Okay.
Okay? So run is the horizontal distance between points, and it's positive if we're going right, and it's negative if we're going left. So let's take this, I'm going to let you finish writing. So let's calculate the slope of this line. We'll go from P2 to P1 this time. Okay? So if we're going from P2 to P1, am I going up or down?
Down.
How many units?
2.
1, 2. So my rise is really -2. And now, my run, do I have to go left or right to get to P1?
Left.
How many units?
4.
1, 2, 3, 4. So we get -4, right? Isn't it dreamy? No, not really. So negative divided by negative gives us a positive. We reduce our fraction, we get the same answer. So it doesn't matter which 2 points you select on your line. It doesn't matter the order, as long as you're consistent. Okay? And it'll always work out to be the same slope. Basically, the ratio between 82 points is always the same. And we talked a little bit about that last unit. When we talked about that boy walking to the store, we knew he was walking at a constant rate because of the straight line. Okay? So there's a little bit building upon that. Any questions on the rise and run? Good, Katie? So now let's go back to that first example, and let's calculate the rise and run of each of these.
I can't see the numbers.
It should be on yours, it's the same one.
Oh.
Just pick random two.
You can pick random 2. That was nice. I actually put some points on there for you that you can reference, but you can put any 2. Now the key to picking your 2 points is, let's say I'm looking at the blue one. So I want to pick this point here, like right there.
No.
How come?
Because that's not a specific number.
Yeah.
Decimal. So you want to have one that's in the intersection.
Exactly. So we want to try to find a point that's on the line where we know exactly the coordinate. Does it work out to be a fraction or a decimal? Hopefully, one of those things, one point on that line, lands on what Megan called like intersection of 2 integers.
What would you call it?
Intersection of 2 integers.
Could be the two.
So I sort of did that for you. Veronica from my last class threw me off and picked a point that wasn't on there. It made me really mad. She picked like this point over here. So
Yeah.
what you're doing. You can't think for yourself, not in my math class. Right? So for M, which points are we going to choose? A volunteer. Who's going to pick 2 points for me? Anthony. Any 2 points on the blue line? Or line 1 on your sheet? Yeah, which one? This one?
Yeah.
This one or this one? 1, 2, or 3? 1 and 3, so 1 here. So we'll call this point 1, and this one we'll call this point 2. For kicks, what's the coordinate of point 1? What's the coordinate of point 1? 0, 1? Right? No? Trying to trick me up here. I won't believe you for a second. 1, 0, right? X coordinate first, or independent variable first. Amuse me. Write it down. What's the coordinate of point 2? 5/8? Or 5,
Why
8?
are you doing so wide? What? I just thought it was
Okay. So what's our rise in this one? How many do I have to go up or down? Put it on your sheet.
8.
8? So 8. And what's my run? How many do I have to go over? I'm gonna double check. I don't believe you guys. 1, 2, 3, 4, 5, 6, 7, 8. Good.
You know, that's really not nice.
5? 5 over? 1, 2, 3, 4.
Wait.
Oh, it's like 8 minus 0,
The answer
and then
4.
5 minus 1.
Oh, the answer. Well, somebody said 5.
Well,
So
they're
that's
wrong.
right. So what's my slope curve? 2.
I said it had to be a fraction. Or a ratio. It is fraction.
Good question. I thought it had to be a fraction.
Or a ratio. Simplify.
2 is a fraction.
That technically is
Remember, every integer is a fraction. We talked about this way back in the first unit. Every integer is a fraction. It just has a denominator of 1, right? We never write the denominator of 1.
I have a question about the
So the green one? Okay, so let's do the green one.
How would you, two, if it's 2 over 3, how would you use it?
Okay, yeah, let's just question? Or you want to do it?
What do you mean by putting it in a ratio? Is it just like the same thing?
Yeah, basically, your slope will always be a ratio or a fraction, right? In this case, we don't write the denominator 1. The slope is just 2. But in concept, your slope is always a fraction because it always rise over run.
Is the ratio the same thing as fraction?
Yes.
Like, well, is it two something or just two? Like,
Just 2. Your slope is just 2. M is equal to 2.
just two?
Yeah.
We'll talk about that a little later.
That's the slope.
Okay. We'll have to put it into context. I agree. We'll put that a little bit later. Okay. Hold on for your question.
Okay.
Okay. So how do we get the slope of the green one?
Take the first one.
Okay. Megan, what's the first point? Choose one.
Right on the.
This one?
right-
This one?
Yes.
So P1.
And
You
then
guys are so boring.
it's not blue. On
This one?
two.
Yeah, it is. It actually is.
Oh, that one.
So P2. Okay. So what's our rise then here?
Two.
Rise is 2, going up 2, and our run is 3. Can we reduce that anymore? No. So let's humor me for a second.
I'm trying to like.
I don't like that blue one. I'm going to choose this one over here. Okay? So we'll say that's P2. So what's my rise to get to that one?
Go five.
1, 2, 3, 4.
Oh, awkward.
Awkward, yes.
And six.
Now you know why I kind of comfort myself?
And six.
6 over. 1, 2, 3, 4, 5, 6.
It's the same thing.
It's the same thing.
Yeah.
So that's what we'll find with a linear equation or a line, is that you can pick any 2 points on there, you will always get the same slope. That is the definition of a straight line.
Wow.
You will always get that constantness. Constant of variation. We learned that last class, right? Constant of variation. This really is our constant of variation. Slope, constant of variation, steepness, all meaning the same thing. Finally, the last one, line 3.
Wait, so the answer is just 2 over 3?
That's just 2/3, yeah. Don't give me a decimal. So sort of what we did in the rational, sort of numeracy unit. Leave all your answers as fraction and improper. What's the slope of the red one? Points. Just gonna choose it for me. Make it interesting.
6.
Choose this one first. How about that?
Let's choose the last.
And this last one.
Oh, that's not interesting.
So rise over run. So go from P1 to P2. How many have to go up or down? First of all, we're going up or down.
1, 2, 3.
Am I going up or down?
Down.
Go from P1 to P2. You're going up. 1, 2, 3, 4.
Oh, no.
No.
Now I'm not going to the left or right to get to the other side, to the other point. Left. How many? Well, how many first?
Well, 8.
8. 1, 2, 3, 4, 5, 6, 7, 8. Because we're moving to the left, right? Because we're moving to the left, it's negative. Stay with me, please. We reduce that to negative a half.
Wait. Make it.
It's negative because this line is going down, right? So sort of remember we have the negative trend or a downward trend. So now can we mathematically show which line is actually steeper, 2 or 3, or less steep? Line 2 or line 3?
Line 3. Well, I don't know, like.
Line 2 or line 3?
3.
Line 3.
Which one is less steep?
Line 3.
Why line 3?
1 over 2. And Megan's
19. So that's 66% steepness. And that's
Just wait. We're being interrupted over here a few times now. We good?
Yes.
Thank you, Dean. Continue, please. So what's your explanation of why line 3 is less steep than line 2?
Because the non 2/3 is greater than 1/2.
Yeah, so in terms of looking at the steepness, we just want to look adjust the number. Forget negative versus negative or positive. Which number is less than the other one? That tells you it's less steep. Or which one is greater than, and that will tell you which one is more steep. So in this case, because 1/2 is less than 2/3, 2 is less steep. So sometimes just by looking at the line, it's hard to tell, but we can show it mathematically, we figure out the slope. Okay, any questions?
It's 3.
Line 2 is less steep, because 1/2 is less than 2/3.
You're getting 2 and 3 mixed up.
Yeah, 1/2 is more than 2/3.
1/2 is more than 2/3?
No, it's
No,
less.
No, wait, if you switch.
Isn't it?
Yeah, isn't it? Isn't it?
It is.
If I give you
No, it's
If I give you a
not.
pie. If I give you a pie.
I give you
I'll
half
take-
the pie.
I'll take the one that's 2/3 of a
Never
pie.
mind, wrong.
Because if you multiply it and get the common denominator is 6.
Okay.
Well, it's still line 3.
I'm gonna try.
So line 2 is less steep. Oh, sorry, line 3.
Yeah, that's what
Sorry.
they were all trying to say.
Sorry. Line 3 is less steep.
Thank you. Why are you looking at me like? Why are you being?
I was just focusing on the red. The red match, that's all I was looking for.
Oh,
Okay.
Still didn't match.
Oh, okay, I get it.
Now let me go back to line 1. I want to show you that's interesting. Something that's interesting. So for line 1 we have point 1. What's the coordinates of point 1? Okay.
It's 5.
Well, it's 1 comma 0, right?
I'm sorry, I'm getting it wrong. 1 0. I was looking at Auckland.
Okay. So what's point 2? 5 comma 8? Okay. So what would happen if I actually called this x1 and y1? Okay, so just from point 1, I have my x coordinate and y coordinate, right? Because it's point 1, I'm going to label it 1. And for point 2, I can do this in another color. I'm going to have x2 and y2. So that's point 2, right?
Wait, what is X1? Is that X1?
x1 and y1 because it's associated with point 1. And then x2 and y2 because it's associated with point 2. I can actually calculate slope as this. Then everybody watching here, focus. Slope, same as rise over run. This is the same as taking y2 minus y1 over x2 minus x1. So your rise is really your y coordinates subtracting one another.
Why is 2 first?
It doesn't matter. But you need to keep them the same. So if you're going to put y2 first here, you need to put x2 first down here. You need to keep that order. Right? So I'm just going to go y2 minus y1, how I remember it. And at the bottom, I need to keep that consistent. Yes, Pooja.
Like, why would we calculate all this? Because without calculating, I could have told you that line number 3 is the least steep.
Sure.
But he wants us, because we're in math class, he wants us to.
So what happens if I drew a line that was like 14, 16, and 15, 16 steep? Would you be able to visually see that difference?
Okay, I can.
So that one maybe is, your eyes are better than mine. I'm old and decrepit. I can't see very well. Alright? So I need to do the math.
Alright.
Okay?
So you're making us do the math to do it.
Sure. Because at some point you get old and decrepit as well. I can't stay here forever.
That's what we already went through earlier.
Okay, so let's get back to this example. Let's get back to this example, guys. So here, what's the value of y2? It's 8. What's the value of y1? 0. So 8 minus 0. What's the value of x2? 5. The value of x1 is 1. So I got 8 over 4. that also gives me 2. Okay? So that's another way that you can calculate rise and run. If you know the coordinates, of your 2 points on the line. Okay, you don't have to do the counting thing, although you know what? Nothing wrong with that. Do whatever it needs to take. But if you're just given coordinates, you don't actually have to physically draw your line on a graph or anything. You do counting, you just do it through math. Just gotta remember that formula. Questions? Does not have another question? I know I got tons of questions, as usual. I have a point. I need to pass out some graph paper. Take some, pass it across. You guys can share this. Take some, pass it across. Take some, pass it across. So I made some grid paper with a larger grid. Now let's move on. I don't want to cut to your lunchtime. Well, I'm more than willing to. Okay, so I'll give you a grid so that you can write this. You can see a little bit more clearly the bigger grid. Take more than one if you want. I have plenty of extra in class. No. Well, actually, write down the question. Okay. Doesn't matter. However you want it. So just write the first one first at least. The point A, -2, -4, is on the line that has a slope of 4/5.
Wait, there's no numbers on it.
Yeah, you put your own numbers. I know.
Oh,
It's a challenge.
making me do the work too.
Wait.
So a point A, which is -2, -4, so we'll put that right here. We'll label it. It has a slope of 4/5. Determine the coordinates of another point on the same line as point A. So we have a line that has a slope 4/5. We know it passes through A. What is another point on this line? How can we determine that? Yeah, but we said that this line has a slope of 4/5, right? So yeah, I mean, I can put it on a point, but we want this line, or this line has a slope of 4/5. So how can I get another point on this line?
On that line.
Yeah, so we haven't drawn it yet, but we want to draw this line. We know it goes through -2, -4. We know that this line has a slope of 4/5.
Oh,
How can I get another point on this line? Because once I have 2 points on the line, I could draw that line. So how can I get another point on here? I feel bad because I sort of put Paul down. I apologize. Paul, go ahead.
alright, so with 4/5, you know that your rise is, so slope is rise divided by run, and it's 4 divided by 5, so now that your rise is 4 and your run is 5, so you can just go down 4, so you can just go down 4 squares from point A, and then across 5 to the left,
Okay.
and then that is your other point from the line.
So I'm gonna reverse what you said a little bit. When you said rise is 4/5, because you're going down, right?
But that's because we have to find.
So you're going down. So this is really a rise of -4, right? And because you're going to the left, this is so basically. Actually, let me rewrite it like this. You have 4/5, so our slope is 4/5. This is really the same as -4 over -5, right? So what Paul is saying is that, well, we want to go down 4, 1, 2, 3, 4, and then over to the left 5. 1, 2, 3, 4, 5. So here we have another point on our line.
Wait, go down from 4, 1?
Yeah, how'd you get?
Well, because Paul wanted to go down, so what we're going to do is do 4/5 the same as -4, -5, right? So here we're going to go down 4 to the left
So
5.
why are we going down 4 from 4?
Well, so you just chose random.
Because this is where our point was, -2, -4.
Oh, it doesn't matter where you go because you'll still get the same. Like if you go up.
Well, we go up and to the right.
It was just what depends what you.
Sorry?
It doesn't matter what numbers you choose, like.
No, we have to choose 4/5 because that's the slope.
Yeah.
Our slope is 4/5. Okay?
It doesn't matter.
I didn't even see that.
So you have to go back to the one. Okay? So what Megan was saying, well, I think you were trying to say is instead of going down and left, we just go up 4, right? So this is positive 4, so we just go up 4. 1, 2, 3, 4. And the 5 is positive, so we'll go over to the right 5. 1, 2, 3, 4, 5.
Actually, I was just wondering why you started from point A.
Oh, we started from point A because we said that the line A is on that line. Okay. And what we'll see is that if I draw a straight line from this point to actually this point, right, that line will go through all those points. Because it's a ruler. Something you're supposed to bring to every class, right?
Do that. Oh, so
Hey, thanks.
you blew my mind, Mr. Dick.
Okay? So that's how we get, so what's the coordinates of the green point? So we'll call this B. What's the coordinates of the green point? -8, -8. No, it's not -8. I did something wrong.
Yeah.
Did it go over too much? 1, 2, 3, 4. Oh, I missed it.
Where's the bad?
I went down for 1, 2, 3, 4, 5. I missed it. 1, 2, 3. That's -7. I just can't. So -7, -8. So that's one valid answer. What's the blue point? We'll call this C. What's the value of that point? 3, 0? Right? There are an infinite number of answers to this question, which makes my life miserable. Because you keep going, right? I keep going. 1, 2, 3, 4. 1, 2, 3, 4, 5. So here's another point. And I keep going. They all define my line. Okay, so let's look at point B. Okay, so good that we're all excited about slope. Questions? Sorry, Jenny? You don't know where the other points are? Well, did you get -2? So -2, -4 is here. So you have to plot A first. -2, -4. So Jenny, look up here. Okay, guys, bear with me for a second, please. So here, the point is A is -2, -4. So we're going to plot that, which is right here. So did you plot that, or yours? -2. So -2 to the left, and 4 down. -2, -4. And that's where you start counting from. Okay. So point B, -5, 6. That's here.
Are we doing another one?
We're doing another one. The point B, -5, 6 is on another line that has a slope of -2. So determine the coordinates of another point on this line.
I'm
So first plot B, -5, comma 6. Get that? Plot -5, comma 6. Right? Now, B is on a line that has a slope of -2. So how do we find another point on this line? That went up 4, back across, because that's the slope.
That means it has to be one positive, one negative. On that side?
Well, first of all, is this a fraction? Slope needs to be a ratio, right? It needs to be a fraction. -2 a fraction.
No, but over one. Yeah.
Jenny, Katie? Here, please. Okay, I don't want to have to explain this again. Alright? So we have point B, -5, comma 6. We have a slope of -2. Is -2 a fraction? It is. What is our denominator? Not it could be.
2.
What?
So that's the denominator of 1, right? So that's the tricky part of this question. Somewhat tricky part. So here, what's my rise? Well, slope is equal to rise over rise. So what's my rise here? Pooja?
You go down to negative 2.
So -2?
Yes.
And my rise is?
1.
Okay. So here we want to go over to, down to?
Yeah.
And to the right 1.
Yeah.
So here's another point, which is -4, comma 4. So that's one answer. And I've gone up to the left one. So basically put the negative, this is equal to 2 over -1,
Yeah, no. Yeah.
right? So I could have gone up to into the left one as well.
So would you have the same slope?
This would be the same slope, but now it's just another point. Here is 6, -8. -6, comma 8.
So like, aren't you not allowed to have the negative?
I'm not allowed to have what?
The negatives and the denominator?
I just moved it down there just to illustrate that we could go up 2 and to the left as well. Okay, just to get another point. Okay. Any questions on this?
No.
So we're given a point and a slope. Given a point and a slope, we can find another point that's on that line.
This is gonna be on the test, because I'll be on the future.
Of course.
Too bad.
I wouldn't be teaching if it wasn't, right?
Oh, yeah, but it's not a very easy thing to learn.
So here's an interesting question
Good idea.
that I have 10 minutes to do.
Do I have to write this down?
Yes.
I love going for on Saturday morning.
So Megan is on the volleyball team and goes for a run every Saturday morning, which apparently she loves to do.
Did you have to write this down?
Yes, please.
Sorry, guys. Write it down. You write it wrong.
There's a place where you keep notes. Called notebook.
It's also the bottom here.
So she has a slow run for 1 kilometer to warm up, which takes her about 6 minutes. She then proceeds to run at a constant pace. Yes, please. You've asked me so many times, you're gonna finish writing by now. So after 20 minutes from the start, Megan has ran for a total of 4.5 kilometers.
That's a lot.
Yes. You're an athlete. Question is, what is Megan's running speed? Running at a constant pace. After 20 minutes from the start, Megan has ran for a total of 4.5 kilometers.
Hate when
Not a real problem.
Yes, it is.
There are words in there.
It's
Have
you
you noticed
running.
that-
It's a you running problem.
Have you noticed that math is the only subject where
I don't have
question
any problems.
is called a problem? And that's which is a lot. Because like it's not called a question, it's called a problem.
How far would she be from the start after 30 minutes as well?
it's pace, not rate.
Failed.
Pace and rate, same thing.
Questions are called problems, it means you can't solve any of those.
So where might we begin?
I'm not done.
I'm trying to answer this question.
Finding out that constant pace.
Well, first let's start off simple. What are the two variables? What are the two variables that we're dealing with?
1 and 6. And
Not numbers. What are our variables? What units are we dealing with?
time and distance.
Time and distance. So time, which is minutes. Right, so we'll call that t. And what's the other variable? Distance? D.
What is rate?
So our distance is in, what do we have in kilometers?
Megan has
And we'll call that D. So which one is the independent variable and which is the dependent variable? Which one is the independent variable and which is the
independent variable
dependent?
is time, independent variable is distance.
Yeah.
And I totally.
Megan, thank you for putting your hand, what's the answer?
Independent variable is time. What's my question?
So independent is T.
Yeah.
And dependent is,
D.
okay. So we're gonna have coordinated points based on our independent and dependent variables. We're gonna graph this, like we're gonna graph it. So what do we know about Megan's run?
It took 20 minutes to go 1.5K.
Okay, sorry, so 20 minutes. So how do I write that as a coordinated pair? What comes first?
Time.
Time, so that's 20,
So 20, 4.5.
4.5. So we can view that as 0.1 on Megan's run. Right? After 20 minutes, she was 4.5 kilometers away. What else do we know from this problem? Vince,
That she had a slow run for 1 kilometer to 1 walk, and it took her 6 minutes.
okay, so what does that tell us about her distance and time then?
That the time is 6
The time is 6, so at 6 minutes,
and 1.
where was she? 1 kilometer. So what is her rate?
3.61525.
So we're going to plot this. We'll have 6.1 to 24.5. So what rate really is we learned from the last unit, the boy walking, is really we're trying to figure out the slope between these 2 points. Okay? So here we got slope is equal to rise over run. What was the other formula that we learned? Since we're not going to count this, we're not going to plot it. What was the other formula that we just had a while back?
Wait, we're not going to plot it?
No, because I'm not a fan of graphing all the time. If these were big numbers, it'd be tough for me to do. Jenny?
Y2
Y2
minus Y1 over X2 minus X1.
Okay.
Don't even look at
So now that I have my points here, I'm going to call this x1, y1. After my point 2, this is x2, y2. So I just plug into my formula. So here y2 is 1, y1 is 4.5, x2 is 6, x1 is 20, Right, so I got 1 minus 4.5 and 6 minus 20. Does it really matter? Gonna matter which order I put those in? No, as long as I keep the consistency between x1 and y1. Okay, so here I get negative 3.5 divided by negative 14,
Why is y on top?
because y is the rise. When we look at the y coordinates, they go up and down. So that helps us define the rise.
Can't you just count your rise and run? Oh no, yeah. because
We haven't
talked about that
plotted it.
last time.
So pull a calculator, negative 3.5 divided by 14, negative 14.
Zero point.
0.25 kilometers per minute. In other words, she runs a quarter of a kilometer per minute, which is pretty fast. Any question over here, Jenny?
Does it matter if you put X, Q, and Y?
Sure.
Like, never mind, I got something.
Right? Okay. So that's your running speed.
That's fast.
That's pretty fast. 4 kilometers a minute.
She actually really fast.
Alright.
Sorry, 1 kilometer for every 4 minutes. That's 15
yeah.
kilometers in an hour.
How many kilometers is a mile?
2.6. Okay, I will take up the second question. Key concepts, you guys have got most of these already.
Do we need to slow down? No, we're ready.
You know what I'm gonna do? I'm gonna send you the PDF for this. No. On condition that you actually read it and do your homework.